Okay, have you ever been curious about calculus? Now, of course, those of you out there that have taken calculus know what calculus is about. But for those of you that just know this word and like, yes, it's a very advanced math. It's what rocket scientists and engineers use all the time. It's way too advanced for me to understand. Well, that is not true. So the whole purpose of this video is to try to kind of introduce you or explain some basic concepts about calculus. And of course, I'm going to try to do this at a very basic level. So there is no real kind of like, math prerequisite required to watch this video, right? You don't have to know some advanced algebra. Of course, that would be nice. So again, if you have no real strong math background, stick around for a few minutes and I can assure you, you'll have some basic understanding of what calculus is all about. Now, before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So, if you're interested in learning mathematics or need assistance in math, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if you enjoy this video, don't forget to hit that like and subscribe button before you leave. Anyway, so let's go ahead and get into it. So my question to you is, what do you think you know about calculus, right? Like, you've probably heard of this word, but if you don't know anything, or if you think you know, something about it, put that into the comment section. I think that'd be kind of interesting to kind of see. But let's go ahead and get into it right now. All right, so calculus. Now, before I get into my explanation of calculus, let's just do a quick review on where you take calculus and who needs to take calculus. So here is high school math, and let's kind of do this real quick. Ninth grade, 10th grade, 11th grade, 12th grade. So this is high school, and this will be college. Okay, so college level math, if you will. So for most students, typically in ninth grade, they take Algebra 1, and then in 10th grade, typically students will take Geometry, and then 11th grade, Algebra 2, and then 12th grade, Pre-Calculus. Now, these are for students that plan to go to college. Now, after Pre-Calculus, if you are entering college and you want to study something in the STEM field, STEM, that stands for science, technology, education, and mathematics. So if you're going to do something advanced, like, become a computer science major, a chemistry major, an engineer, a mathematician, etc., well, you're going to have to take calculus, and typically you'll take calculus here as a freshman at a university, and then depending upon your major, you will take a lot more mathematics. So calculus is typically broken up into 1 year or 1.5 years of study, and then you move on to different mathematics. So you don't need to take calculus unless you're in this field or maybe doing some sort of like finance or economics major as well. So a lot of people will have to take some calculus, but again, everybody out there listening to this video is smart enough to learn calculus. You just have to go through the process and preparation to get there. All right, so that's just a little bit about when you take it and who needs to take this course. So let's go ahead and get into what calculus is. All right, so the first thing calculus deals with is area. All right, so here I have three basic figures. I got a mystery figure down here. I'll show you that in a second. But if I wanted to find the area of this rectangle right here, how could I do that? Well, most of you might say to yourself, well, yes, I can find the area of this. This is super easy. It's just the length times the width, right? Length times width is the area of a rectangle, and you would be correct. All right, how about a circle? No problem, we can find the area of a circle. So the area of a circle is pi r squared, where r is the radius, right? So most of you might be saying to yourself, yes, this is easy. I'm with you, Mr. YouTube Math Man. Keep going with your explanation of calculus. All right, how about a triangle? Not a problem there. So that's areas equal to 1/2 base times height, right? So not a problem. We are talking about area, and I showed you three basic figures. And most of you might, already be saying to yourself, well, what's the point here, right? I know how to find the area of these figures because you've given me the formula, right? All right, so now how about something like this, All right. Could we find the area of this figure? Now, this figure here kind of looks like a bit of a rectangle, but up here there's a curve, all right? This is not a trapezoid. This is like it kind of curves like so. So, what is the area of this figure? Now, some of you might be saying, not a problem. I can find the area of this figure. I just need the formula. Well, there is no formula. Unfortunately, I have no formula for you. So, how do we find the area of this particular figure? And I don't even know what this figure is called. It might be some sort of wedge. Well, guess what? If there's no um, formula, well, we are in a real problem. Okay, so you might be thinking to yourself, well, what do we do here? Well, this is where calculus comes to the rescue. One of the biggest problems that calculus solves, it is able to find the area of all kinds of crazy looking figures, those type of figures where we don't have a formula. Okay, now if you kind of take a look at these figures here, a rectangle, a circle, a triangle, these are kind of, nice basic figures, right? But, in real life, we deal with all kinds of crazy shapes. Things are like this, or maybe something like this, right? That we'd want to know the area of. You're like, wow, how do we find the area of that? Well, we're going to need to use calculus. So this is the number one. Well, there's two big problems that calculus solves, one of which is area and volume. It kind of goes beyond area, but we're going to just stick with area for the purpose of this video. All right, so now let's go ahead and see how this works. But before we really get into the nuts and bolts of calculus, I would hope that you would be able to subscribe to my channel, hit that notification button if you get any value from this so you can get my latest videos. But let's go ahead and continue on with calculus. All right, so again, of course, I'm skipping over a lot of things, but here is our lovely little figure. We're trying to figure out the area of it. Now, let's suppose you're like, well, I don't know if I can get the exact area of this, but you might be able to get some sort of decent estimation, right? So here, this is a rectangle. How about if I just kind of cut this little thing off right there and I find the area of this part, okay? Now, the area of this thing is not the area of this entire figure, but it would be a rough estimate, right? Now, of course, this rectangle here, I can find the area of this by just going length times the width, right? So I can find the area of this shape. And you might be saying to yourself, well, all right, well, that's an okay estimate, but because I used kind of a big rectangle, how about we use two smaller rectangles like this, right? And of course, we know how to find the area of a rectangle. It's length times the width, and here's the width, and here's the length. So here, this is a little bit better, okay, estimation of this little figure. So I'm kind of noticing to myself, well, listen, if I use skinnier little rectangles, I can get a better estimation of the area. And this is a real big concept about calculus, right? In terms of finding the area of figures where we don't have formulas, is if we can kind of find and add up the area of smaller rectangles, our estimation of the area of this entire figure gets better. Okay, so right here, this is pretty good. It's certainly this area estimation is much better than this, but how can we even make this better? Well, we could just kind of like find the area of all sorts of little tiny rectangles like so, and they would just kind of like almost be the perfect area. Right now, of course, I'm writing these super skinny little rectangles, these little strips, but if I can get these infinitely tiny small little rectangles and just add them up, the area of all these little rectangles, I would get nearly a perfect, exact answer in terms of the area of this figure. Okay, so this is a big part of what calculus is about. Is what we call integration, right? We're basically going to effectively find the area of all these little infinitely little skinny rectangle strips underneath here. Now, of course, to add up all these infinite little rectangle strips would take a long time, so we need to use some other techniques in order to solve this. All right, but let's go back to our shape here, and how can we kind of define this exact shape? Well, let's go ahead and talk about that right now. Okay, so for those of you that have some basic algebra behind you, that is fantastic. And if you're not familiar with algebra, you can have what we call a little grid system here, an x-axis and a y-axis. But here we have our curve, all right? And right here, this is effectively this little blue highlighted area is kind of more or less this shape right here. Okay, so this shape right in here, like so, is this right here. Okay, I have highlighted in blue. Now, the reason why I'm doing this is because I want to kind of specifically define the parameters of this shape. Okay. And the way we're going to do that is by giving a rule to this curve. Okay, so you can see here I have a shape that's bounded by this x-axis, and then it's kind of vertical, two vertical lines here, and then this top here is made up of a section of this curve. So if we can kind of define this a little bit better, we can kind of specifically describe this shape that we're trying to find the area of. Okay. Now we need to be able to do this first before we can apply some calculus. And if you stick with me for another couple minutes, I'm going to show you exactly how we're going to find the area of this figure right here. All right, so let's go ahead and get into this next step. So in algebra, okay, which is of course not calculus, I can describe this curve right here, for example, with this formula, okay, y equals x squared, and this is just a rule or an equation of this curve, right? This happens to be called a parabola. So y equals x squared, you don't need to know much about it, but just effectively, we can just describe with a formula this curve here as x squared, or specifically y equals x squared, or the function y equals x squared. So, don't get intimidated by this little technical stuff that I'm kind of talking about right now. But a curve or a shape on an xy plane you can describe by an equation. So this particular equation here, this curve, I can describe as the equation y equals x squared. Now, I'm not interested in the entire curve. I'm just interested in this part here. And let's suppose along our x-axis right here in the middle is 0. This goes negative this way, like -1, -2, -3. This would be 1. And then right here, you can see our little shape is starting at 2 and it ends at 3. Okay, so right in here is our specific little shape that we're going to try to find the area of. Okay, so it's underneath this curve right here, y equals x squared. It's underneath it, but it only goes from 2 to 3 on the x-axis. Okay, so it's again underneath this curve, and it goes from 2 to 3 on the x-axis. This defines this shape. Now, if you understand that, then we could pull all this together to do some calculus, and now this is where the fun is going to kick in. All right, so here is our situation, and we want to find the area of this figure. How can we do that? Not a problem. We're going to use our superhero calculus, and here is some actual calculus notation, and this is what people would see, and they'd be like, oh my goodness, this is like so crazy difficult. There's no way I could understand it. You can easily understand this, okay? So this little crazy figure right here is called elongated S. It's really what we call an integration symbol in calculus, but basically it's saying, hey, let's find the area, okay, let's find the area underneath this curve, x squared, okay, from there, from 2 to 3, from 2 to 3. So that's all this is saying here. Okay, so this is calculus, and again, let me go ahead and just describe this again. It's saying, hey, let's find the area underneath the curve x squared. Okay, so this is the curve x squared, but not the entire curve. We just want to go from 2 to 3. So this is what we call the bounds. Okay, we're going to start from 2 and we're going to stop at 3. So this little dx here, that's a little calculus notation. We don't need to talk about that right now. But if we could figure this out, we're going to actually find the area of this shape. Okay, and this little integration symbol here is also kind of, in some respects, going to, it's kind of saying, hey, let's go ahead and add up all those little infinite strips underneath that curve between 2 and 3, and when we do that, we'll get the area. Okay, now of course, we're not going to calculate the individual areas of those strips. We're going to do something much easier. So in calculus, just like in other mathematics like algebra, there are rules, okay? There's little procedures and things that we can follow. So this is not that difficult. So again, this is called an integral. Okay, what we're doing here is integration, and this is a huge part of calculus, all right, in terms of the problems calculus solves. So this is not that difficult, all right? So let's go ahead and actually do this problem. So we're going to integrate x squared from 2 to 3. All right, so here is the rule in calculus, and there's different rules, but this is, I'm going to show you here that calculus doesn't have to be difficult. All right, so here we have our x squared. So the rule states the following. And of course, I'm kind of, oversimplifying, but no problem. This is really, again, taught or I'm teaching you at a level, a basic level here, right? So x squared, what we're going to do is going to take this little exponent here and add 1. Okay, so 2 plus 1 is what? It's 3. So we're going to write once we add 1, we're going to write x cubed. Okay, so we're going to take this 2, add 1, so we're going to write x cubed. All right, so that's what we're going to do. And then our answer, whatever we got here, when we did 2 plus 1, of course that's 3, we're going to divide that whole thing by 3. Okay, so let me go ahead and walk through that one more time, just so you understand this is not difficult. So we're going to take our x squared, we're going to add 1 to it. That's going to be x cubed, and then whatever this number is, we're going to divide by it. Okay, so we're going to have x cubed over 3. All right, so we're taking this integral, this calculus integral, and now with this little x cubed over 3, we can actually compute and calculate the precise area of this shape, okay, that runs between 2 and 3. Remember, that's what we're trying to do right here. We're going to find the area underneath this curve between 2 and 3. So let's go ahead and calculate this right now. All right, so we're going to take this x cubed over 3, okay, and let me go down here. All right, so remember we just did this little integral thing. We're going to take this x cubed minus 3, and we're going to subtract it from itself, okay? But we're just going to write it this way. So this x right here, this represents a number, and this represents a number. What we're going to do is we're going to plug in 3, this top number right in here, and then we're going to plug in the bottom number over here, okay? We're going to replace these x's with these respective values. So again, right here, we're going to plug in a 3 for x, and right over here, we're going to plug in a 2 for x, right? So 2 comes from this 2, and 3 comes from this 3 right here. This is our upper bound and our lower bound, okay? So we're going to go ahead and plug in these x's with these respective values and do the number crunching, and then we will be done. All right, so here we go. So we're going to have 3 cubed over 3 minus 2 cubed over 3. 3 cubed is 3 times 3 times 3, which of course is 27 over 3. 2 cubed is 2 times 2 times 2, or 8. So that's 8 over 3. So 27 minus, we have a fraction here, right? So same denominator. So 27 minus 8 is 19 over 3 when we subtract these fractions. Not difficult math, right? So 19 over 3 is the area. And if we find an estimation of 19 and we divide it by 3, we'll get approximately 6.3. Okay, so what does that mean? Well, that is in fact the area of this crazy little shape right here. Okay, we just actually computed the area. So the area of this shape right here, bounded underneath the curve x squared between 2 and 3, is approximately 6.3 units squared. All right, so we just actually did a calculus problem, an integration problem. And notice the arithmetic I'm doing here. It's not that difficult, right? I mean, I'm working with some basic numbers. This is some fractions. Nothing too crazy. Hopefully, you have a sense of what's going on. Remember, calculus, now I'm not kind of dismissing that calculus is an advanced math. It is indeed a very advanced math, and there is a lot to learn. And I am skipping over a lot. But really what I wanted to kind of do here is kind of demonstrate to you that, calculus is a language, right? It's just like a language you're trying to, learn. Maybe you're trying to learn Spanish, Chinese, German. If you don't know the language, of course, it's going to be difficult when you hear it or see it, right? But as soon as you know the words of the language, or you start getting a feel for, the different nouns, verbs, and whatnot, you can kind of piece it together. Calculus is no different, right? It's just another mathematical language. Okay. And again, when you see these symbols and whatnot, they're telling us to do something. All right. Because you'll never be overly intimidated by things you don't see in math. They're just things that, you just have to learn, all right, obviously, right? So, don't be like, oh my God, calculus it's so advanced because I don't understand what these symbols are. No, of course not, right? Just like any language, if you don't know what it means, you know, it's going to be mysterious. But I'm telling you right now, if you have some sort of interest in calculus, you absolutely can learn the subject. And I would definitely encourage you to learn calculus because it is a fascinating and super powerful mathematics, and indeed it is used pretty much everywhere in modern engineering, technology, etc., etc. All right, so hopefully I've done somewhat of a decent job to explain calculus at a basic level. And if you feel like I've done an okay job, don't forget to hit that like and subscribe button. And with that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.